technique to merge them is to put one under the other. So you take lab 2 and put it under lab 1. That's like a longer table. But somehow we have to tell R that these things come from lab 1 and these things come from lab 2. We achieve that by adding one additional column called lab. So I have got one additional column called lab, which says that in this case all these things come from lab 1 and all these things come from lab 2. So now I have got a table with 3 columns. WA lab. Observe that in our black box we have exactly 3 arrows other than this unobservable random error. I have got W, and you see I indeed have one column for that. I have lab, I have another column for that, and I have the output L, I have one column for that. This is always going to be the case. You will always have exactly one column per arrow in the black box diagram, irrespective of what model you are going to fit. So this data layout will always depend on only the black box diagram. Okay, so now that we have this, it will help if we just express symbolically all these quantities in a slightly different way. So earlier we had called these things WIs and LIs. Now, once we have this factor input, a more useful way of denoting this thing is by using 2 subscripts. Now, understand this carefully. Whenever there is some factor input, you must dedicate one subscript for that factor. And one subscript, we might say, is dedicated to the random error thing. So earlier we had only weight and length. We did not have any factor input. So we had only the random error. So we used only one subscript. In this case, I have got lab, that is a factor input, and I have dedicated the first index, I, to that lab. So here, for example, Wij means the weight that you hung in the jth trial in the ith lab. For example, what is W11? W11 is this 1.0. Lab 1, trial 1. W12 will be this 1.5. Lab 1, trial 2. Similarly, W21 will be lab 2, trial 1, that is this 1.2. And this is W22, W23, W24, W25. So J basically indicate that when your factors are all at a particular value, fixed at a particular value, you are just carrying out the experiment again and again. That's why I just say, just remember that it is dedicated to this random error. So that is the idea. You are doing it again and again with the same setup in terms of the factor. The covariate may or may not change. In this case, the covariate has not changed. Also notice that the J index, the range of the J index may depend on I. When I equal to 1, J runs from 1 to 6. When I equal to 2, J runs from 1 to 5. Similarly for Lij, the measured thing for Ij, similarly for epsilon Ij, the errors, which are not measured, but you will need them when you want to write down the model. With this thing, now we want to write down the model. Remember, the box diagram dictates the data layout. The box diagram does not completely dictate the linear model. With the same box diagram, we may have different linear models. We have already seen that linear regression and quadratic regression both use the same box diagram. In this case, what should we do? Let's see. We have the idea that the springy nature of the spring, the elastic property, that will remain same in either lab. Indeed, that is what we are going to study. Possibly that is made up of steel, of a certain pitch and a certain radius. All those things are fixed, and we want to study the elastic property of springs with those things. The initial length is not of much importance. So in this case, a natural model will be this. Lij will be expressed as again a linear regression, but the intercept term, which you understand, has to do with the initial length that is allowed to depend on I, that is the lab index. Then beta, which gives you the elastic property, that is independent of I. So this is what we are primarily interested in. So I have got alpha 1, alpha 2, I has two values. Those are parameters but not of primary importance in this example. Beta is the parameter of primary importance, then Wij plus epsilon ij. So this is one possible model. If on the other hand you have a different setup, for example, you know that the initial lengths are the same, however, in one lab you are using springs made of steel, in the other lab you are using spring made up of some kind of, say for example, aluminium, in that case it is beta which will change. So this is that particular model that we are going to study. Observe that alpha, the intercept, now depends on I, beta, the slope, does not.